exams, which is crazy that we're talking about exams already, isn't it? Man, crazy how fast the school year is going. All right, so you're going to do day 1 notes and day 2 notes together in class. Okay, so let's take a look at day 1. Day 1 talks about completely factoring. And a polynomial is completely factored when the products cannot be factored anymore. Okay, when you cannot go any further. What's the first rule of factoring always? And we're not going to do the 3 that are on there. We're going to add a different one. GCF. After a GCF, you ask yourself, do I have a what? Uh-oh. We always look for GCF first. Then you ask yourself, do I have a binomial, which is 2 terms, a trinomial, which is 3 terms, or do I have a 4-term polynomial? If you have a binomial, you ask yourself if you have a difference of squares. What's the difference of squares formula? If you have a squared minus b squared, it becomes what? A plus b, a minus b. Okay, or a minus b, a plus b. It doesn't matter. Do you guys remember that a little bit? We're going to add another one to the binomial column today. If you have a trinomial, you ask yourself, is what? Is a 1 or is a not 1? If a is 1, life is easy. You just factor. If a is not 1, you multiply the first and last term, split it up. Okay, we'll do some of those today. And here, you just group. So hopefully you remember that a little bit. Okay, we're going to start here. Factor each polynomial. We're going to skip all of those and we're going to add D. So if you could, go down to D. Just on the front where you guys were. Okay, you had A, B, and C. You had A, B, and C. There is C. Just cross those out or wherever. Just underneath one of those on the top. Now at the very, very top, underneath example 1. Okay, you can just add this one underneath it. So on the top part of your notes, you have your guided notes. You have 3 problems at the very, very top. You're not doing those 3. Put this one instead. Okay, first rule of factoring. So Laura, what is our first rule of factoring? Is there a GCF? So is there a GCF? If there is, what is it?
X.
Okay, part of it.
Wait.
So look, you have an X, but how many can you take away?
Is it X squared?
It is X squared, okay? So you can take away, because you have 4 of them here, 3 of them here, and 2 of them there. So the most you can pull away is 2. So when you take away X squared, Laura, what do you have left?
10x squared plus x minus 2.
Okay, are you good so far? And now is a 1. You have a trinomial left. Is a 1. So what are you going to do? Do you remember? Multiply what? So 10 and what's 10 times negative 2? And you're going to ask yourself what?
Multiplies to get negative 20 and adds to get 1.
And adds to get 1, the middle term. Very good.
Wait.
Don't overthink it.
No, I'm going to overthink it.
What is it, guys?
5 negative 4.
5 and negative 4. Laura, do those multiply to give you negative 20? Do those add to give you 1? So we're going to split this up. So here's what I do, because do you guys know what you'll forget? By the way, you cannot divide by x squared because you do not have an equation. You can only divide by your GCF if you have an equal sign. I don't have an equal sign, so I got to keep that out there. I'm going to draw an arrow so that I remember to put that down here with the answer. Don't forget it. And now, Laura, I'm going to break this up. So I have 10x squared. And then which one do you want to put first here?
5.
So plus 5x minus 4x minus 2. And that's a legal move because if I combine my like terms, I get back up to x. Now, factor by grouping. What can you pull out of these guys?
5x.
And when you do, what do you have left?
2x plus 1.
2x plus 1. What can you factor out of these two? Being very careful because the leading term is negative.
-2.
And -2. The only time you factor out a negative is when the leading term is negative. 2x plus 1. Double check that. When I redistribute, do I get -4x plus 2? Minus 2. So now I have the same thing. So what did this factor into?
5x minus 2 and 2x plus 1.
5x minus 2 and 2x plus 1. Now we have to ask ourselves, am I done? Can these binomials go any further? Anytime your binomials have a degree of 1, they're linear, you're done. You're done. So we're finished. This is as far as that problem can go. She factored. Questions on that one? Are we good there? Okay. Well, now underneath binomial, we are now going to add the sum and difference of cubes, because everything you guys have seen in red, you did in Algebra 1. Now we're adding sum and difference of cubes. And here's the way the sum and difference of cubes work, okay? If you have the sum of two perfect cubes, a cubed plus b cubed, the formula is a plus b times a quantity a squared minus a times b plus b squared. If you have the difference of cubes, it's the same formula, except for you have a minus b, a squared plus ab plus b squared. There's an acronym called SOAP. And SOAP stands for same, opposite, always positive. Okay, so same, opposite, always positive. Notice the signs are the same. So when you have a cubed plus b cubed, it's the same. The opposite, always positive. Same thing here. If you have minus, it's the same. Minus, opposite, positive, always positive on the end. So, somebody's noisy down there. Let me show you two very basic problems. And let's also make a very general list of some perfect cubes. All right. So what's 1 cubed? 1. What's 2 cubed? 8. What's 3 cubed? 27. What's 4 cubed? What is it? 64. What's 5 cubed? Okay, what's 5 times 5? And if you have 5, and then 25 times 5, if you have 5 quarters, what do you have? 125. What's 6 cubed? Do you guys know 6 cubed? 216. And the other one that you'll sometimes see is 10 cubed. Well, that's just a 1 with 3 zeros, so 1,000. All right, so those are some of our perfect cubes. So if I give you the problem x cubed plus 8. Do you have a GCF? No. Do you have two perfect cubes? This is what cubed plus what cubed. So you don't have to do this. This is just what we did, like when I taught difference of squares. What goes in here? And what goes in here? All right, do you guys see that? So now you're going to use your sum of cubes formula. And you just do a plus b. So you're going to do x plus 2. Same sign. Since this is positive, same sign. Now you square a. So I'm going to square x. So I get what? squared. Now the opposite sign. Multiply them together. What's 2 times x? 2x. Always positive. Square 2. What's 2 squared? 4. This trinomial will not be factorable. There is nothing that multiplies to give you 4 that adds to give you -2. You're done. Let's try another one. Let's try x to the third minus 216. X to the third minus 216. Okay, this is what cubed minus what cubed. So what would you guys put in here? X and 6. So now this is what? X minus 6. And then what? X squared. Okay, so this was a minus b, same sign. Now square this. Now opposite sign, so same, opposite. Now multiply them. 6x, always positive, square that. 36. And you're done, because the first one is linear and the second one will not factor. There's nothing that multiplies to give you 36, it adds to give you 6. Thoughts on this? Heard some sighing. Okay, turn it over. Let's do example A and B. See if you guys can do A and B. Just A and B. We're going to skip C. Just A and B for a minute. All right, so page on A, this is what cubed plus what cubed? X in 5. So what did you factor this into? X plus 5. X squared minus 5x plus 25. Same sign, opposite sign, always positive. Done. Thoughts on A? Good. Karina, help me on B. Okay, what'd you do here? This is what cubed minus what cubed?
X and 4.
X and 4. So what did you factor this? God bless you.
X minus 4.
X minus 4.
And then x squared plus 4x plus 16.
All right. Are you guys catching on? A little bit. Okay. Let's try. There will be a sum or difference of cube formula problem on the quiz on Friday. Make sure you know it. Skip in C. Jump to D. Still have to keep in mind your first rule of factoring. So Justin, what is my first rule of factoring?
GCF.
Does this one have a GCF?
Yeah.
What is it?
Something S squared.
Okay, S squared is part of it. And then the leading term is what?
Negative.
Negative. And then what's the biggest number that will divide evenly into 16 and 250? It is 2. Okay? So negative 2s squared. So there's your GCF. Negative 2s squared. So when you pull out a negative 2s squared, what's left?
Yes.
Okay, go ahead, Justin.
Oh, sorry. 8s cubed.
8s cubed. Oh, no, not minus. It'd be what?
Plus.
Why would it be plus? The negative times a positive gives you negative. And what would you get here? 125. Okay, are you good there, Justin?
Yeah.
Okay, factored out a negative because the leading term was negative. A 2 is the biggest number and s squared. Now, what's left is a binomial. You need to see, do I have a difference of squares, sum of cubes, or a difference of cubes? We have a sum. Is this 2 perfect cubes, Justin?
Yeah.
This is what?
8s.
Well, what multiplies together to give you 8 3 times?
Oh, 2.
2s. And this would be what? 5. Okay, so I'm going to bring this down. I'm going to bring my GCF down. And then what does this factor into using your formula of sum of cubes? So first you just do A plus B.
Yeah, so 2s plus 5.
2s plus 5. Now what do you do with this number here?
2s squared.
Okay, close. Remember you have to square this. What's 2s times 2s?
4s.
4s squared. Now what sign do you put next?
Plus.
But same, opposite.
Oh, okay.
And now what do you do with 5 and the 2s?
10s.
10s. Always positive. Square that.
So it would just be 25.
And you got it. Now, you always got to look, can I do anything more with my binomial? No, and your trinomial is not factorable. You are done. All right, how do we feel on that one? Good? All right, now we're going to go. I got to read my. Okay, that. Okay, now we're going to go to here. Factor completely. All right, going back to our rules of factoring. Do you have anything you can pull out of all 4 terms? Addie? Do you have something you pull out of all 4 of them?
No.
No. How many terms do you have? I just told you. You have what?
4.
So remember from our little thing, flow chart, when you have 4 terms, you just group them. Sometimes you guys get to 4 terms and you kind of panic because you're like, I don't know what to do. But you do. You just group them. What can you pull out of those 2, Addie?
Z squared.
Z squared. And when you do, what do you have left?
Z plus 5.
Z plus 5. And then what can you pull out of these 2 terms?
-4.
And when you pull out a -4, what do you have left?
Z plus 5.
Z plus 5. So what do you get when you factor these 2 by grouping?
Z squared minus 4 times Z plus 5.
Z squared minus 4 times Z plus 5. The only thing is, you got to ask yourself, am I finished? Because this one is not linear. The second one is linear, but the first one is not linear. So you got to ask yourself, I have a binomial. I have a difference. Do you have 2 perfect squares?
Yeah.
This is, again, a lot of you will skip writing this, but if you need this, write it. This is what squared minus what squared?
Z and 4.
Z and 2. So what does that one factor into?
Z minus 2.
And?
Z plus 2.
And then don't forget to bring down that.
Z plus 5.
Now they're all linear. You're done. Once they're all degree of 1, you are done. Making you think. There will be some on the quiz tomorrow that are just, not tomorrow, Friday, that are just factor. Notice there's no equal sign, you just factor. Okay? Let's go to the next one. This is okay. B. Ava. First rule of factoring. Do we have a GCF on this one? Can you pull 9 out of 16? Can you pull 3 out of 16? I'm going to tell you there's not one.
Okay.
Okay, so check, but there's not.
There's not.
Okay, so now you have a binomial, so you have a minus, so you got to ask yourself, do I have a difference of squares or maybe a difference of cubes? You have a difference of, I know, is everybody back? I'll shut the door since they're singing out there. Difference of what?
Different squares.
Difference of squares. So this is what squared minus what squared? 4x squared minus
High school spirit club, middle school power of 10, and high school speech and debate team. Please add information to
you just don't want to do this problem. Okay. All right. So what would this become? Lucas, she got it started for you. She said it's a difference of squares. She said this is 4x squared minus 9 squared. So this becomes what?
I have no idea.
Okay. If you had x squared minus 3 squared, that would be x squared minus 9. What does that become? X plus 3, x minus 3 is a difference of 2 squares. So what does this become?
Oh, 4x squared minus 9. And then 4x squared plus 9.
Okay. Are you good so far, Lucas?
So far.
And I said so far because we're not done. Okay? You have a binomial. This one is a plus. So the only thing you could do here is if you had a sum of cubes, but that's squared. So is this a sum of cubes? Is this a difference of squares again, Lucas? This is what squared minus what squared?
4x.
Not 4.
2x.
2x and so what would this one factor into?
2x minus 3.
And
2x plus 3.
and don't forget to bring down the
4x squared plus 9.
now are we done? Yes, because those two are linear. This one is not a sum of cubes. That's the only sum of a binomial you can do. You're done. Okay. Next one. Jack, what's your first rule of factoring? Does this one have a GCF? What is it? 3p squared. Perfect. Let's pull out 3p squared. When you do, what do you have left?
P to the 6. 5. P to the 3rd. 6p minus 6.
Perfect. All right. Now, most likely, you guys are looking at that trinomial, and you're looking at it and you're thinking, I feel like I can factor that, but I'm not really sure because of the exponents. Here's the way this works. When you have a trinomial, if you have whatever degree here, and then in the middle it's half. Okay, so like when we had squared 1 constant, we could factor it. If you have 6, 3, 1, we can factor it. If you have a 4 constant, we can factor it. If I have 10, 5 constant, I can factor. I'll show you how in a minute. But do you see the pattern that I'm telling you we can factor? All right. A is 1. Life is easy. Okay. I'm just going to bring this down. Bring my GCF down. And now I'm still going to ask myself the same questions. What multiplies to give me 6 and adds to give me 5? So what multiplies to give you 6 that adds to give you 5? 3 and 2. Now, here's the way this factors. What multiplies together to give you p to the 6? You can't put p and p because that doesn't give me p to the 6. What gives you p to the 6? P to the third and p to the third. And then what multiplied to give you 6 and added to give you 5? 3 and 2. Now, let's just check that that worked. Okay? if you just FOIL this, what's p to the third times p to the third? And then plus 2p to the third plus 3p to the third is 5p to the third plus 6. So that will work. If it goes 6, 3 constant, 8, 4 constant, 4, 2 constant, 2, 1 constant, which is the ones you guys are used to. Can I factor these any further? They're pluses, so they'd have to be perfect cubes. The front end is, but is the back end. So we're done. All right, questions there? All right, part 2, notes. Okay? I know, we're not done. I told you, we're cruising today. 1, 2, 3, 4, 5.
Are you chilling?
1, 2, 3.
So we found.
1, 2. Okay. So now determine whether or not something is a factor. If it's a factor, the remainder is what? If it's a factor, the remainder is 0. So if it is a factor, the remainder will be, God bless you, 0. So determine whether or not this is a factor. Okay, determine if x plus minus 2 is a factor of that polynomial. Well, I'm going to use synthetic division. Watch. What goes in here? 1, 2, negative 4. Now it says x minus 2, so when I set x minus 2 equal to 0, what do you guys get for x? 2. So what goes out here? 2. If this is a factor, what's my remainder? 0. Well, let's check. What do you do with the 1? Multiply? Add. Multiply? Add? And everybody said, is this a factor? Why not? Okay. It has a remainder other than 0. Okay. Not a factor. Is this more your speed? Yeah. You guys are like going out like this. All right. We'll do this one together. Is this a factor? What are you guys going to plug in? Do I have any holes? I go 4, 3. Ooh. Okay, so 3 what? 15. Negative 1. 0. 25. Did you catch the 0? Now, when I set x plus 5 equal to 0, what's x? So what goes on the outside? What's a 1? Okay, bring down the 3. Everybody, multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. Is it a factor? Why? Remainder is 0. Okay. That's a test question on Friday. Do we like that? All right. Next one. Okay. Next one. Show that this is a factor, then factor completely. Show that this is a factor, and that, so they're telling you x plus 3 is a factor. Yes?
Yep.
So what's the remainder going to be?
0.
Watch. Let's use synthetic division. Okay? If x plus 3 is a factor, when you set it equal to 0, what does x equal? So what goes on the outside? What goes on the inside watching for holes? 1, 3, 0. Just 1 0. Negative 1 and because I have x to the fourth, 3x to the thirds, no x squareds, minus 1x, minus 3. All right, synthetic division. Help me with that one, Olivia. So, Olivia, bring the 1 down. Multiply, you get what? Add. Multiply. Add. Multiply. Add. Multiply. Add. Okay, so is it a factor? Did you just prove what the book told you, that it's a factor? Now watch. Remember when we divided. If you divide, let's just say we divide 12 by 3 and you get an answer of 4. Doesn't that mean that 3 times 4 equals 12? Yeah. Okay. What's my answer here? So when I divided this polynomial by x plus 3, what did I get for an answer? Well, I have to go down a degree. So this would be 1x to the third. No x squareds, no x's. And if I multiply that by what I divided by, which was x plus 3, I didn't divide by negative, I divided by the factor x plus 3. You guys just said, okay, if I divided 12 by 3 and I get 4, that means 3 times 4 is 12. So if I divided this polynomial by x plus 3, that means the answer times x plus 3 equals that polynomial. Okay, now can I keep factor? Now it says then factor completely. Okay, what's left is a difference of
Squares.
not squares. Difference of what? Cubes. This is x and 1. So I'm going to bring down the x plus 3. I'm going to use SOAP. Same opposite, always positive. So what do you guys have here? No. X, x, x minus 1, a minus b. Then what? X squared
Minus 1.
plus 1x plus 1. Now the 2 in the front are linear. The 1 in the back is the trinomial that was created by sum or difference of cubes, and it cannot factor. Let's try one more. We're not doing the back page. Show that x minus 6 is a factor. So what do you guys have in here? 1, -5, -6, 0. What goes on the outside when you set this equal to 0? 6. Everybody help me work with it. Bring down the 1. Multiply, you get. Add, you get. Multiply, you get. Add, you get. Multiply, you get. Add, you get. Okay. Is it a factor like they told you it was? Okay. What's your answer? You started with x to the third, so your answer would be x squared plus x. What was the factor that you have to multiply this by? X minus 6. Because again, if it's a factor, that means that that number times that expression times the expression you factored by multiply together to give you f of x. Now, sometimes I give you this expression and you guys are like, what? Okay, what's the first rule of factoring? Does that have a GCF? What is it? Put it out front. When you pull out an x, what do you have left in that binomial? X plus, and now we are finished. All right. It's big. It's big.